great. So you should my screen somewhere, right? There we go. Great. Okay, so let's start. We're going to talk. It's going to be you, me, and we're going to talk about Java after 11. So the plan is to start with Java 11 code base and then take it all the way to 9, in very quick steps. So this is not a tutorial to teach you how these features work. I'm just going to showcase them so you get away with how much actually changed and how interesting this is, and how much you maybe want to check this out yourself then. You can see the slides online at slides.nipafx.dev, and the code that I'm going to show you is on my GitHub repo, which is .com/x, and then this one is called Java after 8 because that's how the talk started. There's a better repo to repo out to check these features with this demo Java, which goes into more detail and does really to show the environment. Let's talk a little bit about Java 11. It was released in 2018, and free support already ended, but community support and commercial support is plenty to be had. So it is a good release to be on. It's the first modern Java release, meaning the first one that came out in the 6 months release cadence that has a long-term support. It has a very solid feature set, and it is pretty stable, and it has great support by a variety of vendors. So that's all good, right? But things are coming, and Java 11 is starting to fall behind. We have a bunch of new, really interesting language features. We have improved APIs. The JVM is always getting better. We have improved performance, and I want to take a look at each of those things here with you. So I hope that afterwards you feel curious to check out what happened after Java 11. Java 11 we update to 17, and even jump on the 6 months release cadence and update every 6 months with each new release. So let's talk a little bit about code. Let's see some code. So this is a small project that I created. I will summarize from the start, right?
Good.
And let's hope it goes better this time. Like as I said, maybe it was just my Bluetooth headset. I'm sorry if I'm causing technical issues here. Okay, let's try to give it another go. Should I just start?
Yes.
Okay, good. So what the session is about is to bring you to show you how much changed after Java 11. So Java 11 is like the first modern release, meaning the first one in the new release cadence that had 6 months support. That had long-term support in the 6 months release cadence. And so that's a release that many people are on, right? They made the update from 8 to 11, and that's the lot of projects we see are doing that. And then many are considering, should I go from 11 to 17? And I'm basically here to tell you that's a good idea. I want to show you a bunch of the features that come after 11. And then we're going to even go beyond 11, beyond 17, and we're going to look at 18 and 19, and if we have the time, even at the preview features. And what I was just explaining was what the project looks like, and what the project that we're going to code, how that works. But in the interest of time, maybe that's even not that terribly important, because what we're going to do is we're going to look at very specific pieces of code and just with these small pieces and see how they get better and how the new APIs and new language features improve that. So I'm just going to say, let's not spend too much time on trying to figure out what exactly the project does. The overall, it takes in a bunch of markdown files, and it creates a JSON file that says, if you've read this blog post in this one markdown file, why wouldn't you read the other blog post next? So it's a recommendation engine. Okay, so first thing we do is we want to update to Java 12. And for all of those being worried about updates, let me show you how easy this can be. Okay, just go here and say 12. And then you go into your favorite system to switch your Java versions. I use SDKman on Linux for that. That's pretty good. So let's go to 12 here. And first we have to tell IntelliJ to re-import. And now let's build and run this. So keep running this script. The script does nothing magical. It just prints the current Java version. It runs the Maven build silently in the background so we don't get annoyed by too much output. And then it runs the program 10 times. Why 10 times? I want to show you a little bit about performance. But this is a horrible way to measure performance. It's a laptop. That's live streaming. That has other programs running, right? So this is just like the roughest of indications, right? You cannot rely on this. Just like, to give you a little bit of information. So you see, it ran like in 1.4 seconds, and what it created as output was this recommendations JSON file, which looks like this. So let's say you read this article. Why don't you read one of these 3 articles next? Okay, now let's start with something. One thing I want to have a look at, which is an improvement to the completable future API in Java 12, and that is specifically Let me see where. So what we're doing is here we're trying to load stuff from disk, and like different config files, and some of them might work, and some of this might not work. So somewhere here there's some error handling. Let me see. Output file map. Where it go? There it is. Okay, so here's some error handling here. And this error handling is a bit weird, the first one specifically. This is the completable feature exceptionally to call. And it says we're going to call read user config. If you look down here, we see that that also returns a completable future. And then we have to join that. That is weird. Like we have to, like within this lambda, we have to join, meaning wait on this completable future. And the reason for that is that before Java 12, you could not have something like a flat map to a map, meaning an exceptionally that would accept a lambda that returns up a completable future. So the entire completable future API is pretty large because it's a combination of different requirements, and not all the combinations are actually fulfilled. In Java 12, filled in a few, like this one, exceptionally composed, right? So this just makes your completable future code a little bit more succinct and a little bit more powerful. We can now also say, I want to do this in async a manner where you say, like, I want to force this onto something that was also not possible before within the exceptional step. Okay, and that's pretty much what I want to show you already on Java 12. So let's go to Java 14 yet. I'm jumping a few features because there are a bunch of smaller features in here, and we don't have much time. So I want to go quickly get to the really good ones. So let's go to Java 14, which once again means here we have to go to the POM and we switch to 14. So you see how easy updates are? Like all you need is a program without any dependencies. Well, you can update on versions on programs with dependencies, no worries. But this, of course, makes it easier. So let's go to 14. And let's go to type genealogist. I want to show you something there. So what this thing does is it gets two posts, which could be a video, an article, a talk, and it tries to figure out how related they are and whether it wants to recommend the other one. So it needs to give a score. That's what it needs to do. It gets post 1 and post 2 and tries to figure out, okay, given you've just seen post 1, how much of a score should I give post 2? How much would you probably be interested in that? And this one basically thinks, hey, I'm going to recommend a bunch of videos. So videos are always rated high. This is somewhat fictional, but maybe that's what the website wants to do. And this is a very ugly way to switch over that. We're saying I switch over the class name. We're not going to get rid of that yet, but also we have to first the variable, then we have to assign it, and then later we put it into a new value. And all of that is kind of cumbersome. And so Java 14 added the switch expression. So with that, I can do this. This entire thing becomes a value now. And I can say, look, in case it's an article, it should be 50, the score that is. And in case it's a video, then it should be 90. Oh, sorry, the 90 should still be there. And in case it's a talk, I want to score it at 20. And now we have to add a semicolon here. And that's not only much shorter, it also expresses much more clearly what you want to say. Namely, in case of this input value, this is the desired output value. So I want to assign that to the variable that I have here, to the score. So this I use two different new things in Switch. One of them is it's now an expression, which means the thing as a whole can have a value, which I showed you here. And then also you can use the new syntax, the array syntax, instead of the colon, which is generally preferable for a variety of reasons that I don't have the time to go into. But I recommend from Java 14 and forward to always use the arrow, unless you want fall through, but you fall through from one case into the next. If you need that, then you can use the colon. I mean, you can use the colon either way. I'm not the police. I'm not going to stand behind you with this. But I'm just saying I prefer the arrow. So that's one thing that came in Java 14. And I want to show you something else that that might seem negligible, but it's really helpful actually. So let's create a null pointer exception on purpose. Let's go into, where's the create? Here's create. Okay. So here, in this case, let's create here a null pointer exception on purpose. Okay, and now we're gonna build this and run this. And so we're building it, and then we're going to see an error, right? The first time it runs, we should see an exception. There we go. Okay, that's actually a feature of switch expressions that I forgot to include here in my thought process. What happens if it's none of these three cases? Okay, then we just say in the default case, it's going to be a 0. That's what the compiler was complaining about here. The compiler said the switch expression does not cover all possible input values, which we now fixed. Let's see. Building. There we go. Okay. So we enter exception in this location at blah, blah. Let's have a look at the run script. The run script is what actually runs this. It just runs Java from the class path and runs this module. Okay, now there's something cool new, the new thing that is added in Java 14, that in Java 14, yeah, okay, so yeah, screen share also died somewhere in between. Okay, so, but look, what we just did is, well, we had some troubles, and we had some troubles of them intentionally, actually, because, remember I forced a null pointer exception? That was the old way to see this. There's a null pointer exception, there's no additional information. If you add this command line flag on Java 14, or I think on 16 or something, you don't need to add the command line flag anymore. So you go to 17, I'm pretty sure you don't have to anymore. You will get more detailed information. What the null pointer exception will tell you now is cannot invoke which method specifically. So I tried to call on config the method article folder. It couldn't do that because config is null. This gives you much more information, right? And that's, for us as developers, not always the most important thing because we usually do have access to the code. But even then, it's helpful. But it's particularly helpful to people who do not have full access to the code or try to understand issues from logs, for example, like first level support maybe. And for them, this can be really helpful to just get a better impression of what went wrong. So that's another thing that was in Java 14. So now let's go to Java 15. Let's go to 15 on the command line. There's that, and then we go back to the POM and push the POM to 15 as well. I quickly re-import, and now we're going to do something very, very cool, something that Java has been waiting for a long time, and that once you start using it, it becomes really challenging to stop using it again, and that is text blocks. So what I'm doing here is I'm generating the JSON output. Now, this JSON file that I showed earlier, right? The recommendations file. Oh, that's the config. Where's the JSON file? All right, it didn't run recently, right? It didn't successfully run, so it's deleted. But you saw the JSON file. You could argue, why would you create that manually? That's hilarious, right? That's what ridiculous rather. That's what dependencies are there for. And you'd not be entirely wrong. Usually, you don't want to create JSON by hand. But sometimes, I mean, not in production environment, but maybe your tests that, can benefit from that, or maybe you just want to generally create a multi-line output that is not necessarily read by a machine. In this case, it's just 10 lines of code. Do I really want to have an entire library to replace 10 lines of code? Although this code probably doesn't escape everything, but still. So what I'm pointing at is sometimes you need to create stuff like JSON, HTML, something that is two-dimensional text, right? That you don't just want to have in one single line, but something that crosses several lines. And this is what I'm trying to do here, right? I want to have the opening curly brace, and then there's a new line, and then there's some indents, some tabs for indentation, and all of that. And that looks ridiculous. So look, IntelliJ already helps me. There's a text block feature now. And IntelliJ doesn't understand that I like to use tabs, which annoys me a lot. So let's quickly put in the tabs too. And there you go. Look, this is a text block. This is much cleaner, right? I don't have to add, to use indentation, I just use actual indentation. To use new lines, I use actual new lines. And all I need to do for that is start the block with 3 quotation marks and then a new line, right? So the block starts here. Something that you can probably not read that well on the screen, I'm not sure, is that there's a vertical line here, a slightly green vertical line to the left of the blinking cursors. And that's the line where IntelliJ figured out that the compiler is going to count actual indentation. So only this part here is indentation. Only this part is indentation. These entire blocks are not indentation. They are not in the final string. The compiler figures out that I don't want that, and I'm not going to go into details how and why it does that, or rather how it does that. The why should be obvious, because you can format your code as you want to format your code, and then also format the resulting string as you want to result. And those are different things. And it's great that this is done the way it is. We can do that elsewhere as well. So for example, we can do that here. There it's can do it manually this time. Be that, and then a new line, and then this. There we go. Oh, what's that? That's probably some spaces I accidentally hit. There you go. What? Oh, there's leading space. Probably happened when I hit the new line. Let's ignore that. There should be tabs there. And I can do the same thing down here, but I think you get the point, right? You can use text blocks to create two-dimensional text, meaning not just a single line, but multiple lines in a much more natural way. And an added benefit is, since the delimiter is 3 quotation marks, the single quotation mark is no longer special. So you don't need to escape it. You can if you want to, but you don't have to. That also makes stuff like JSON HTML clean to read. If you're doing this anyway, one that you can then do is make formatting a bit easier. So let's say you want to use string.format in different places. I use that here somewhere. So let's see. Let's say I only want to go to Java files here, for example. Let's just go here. So this is a static import of the method string.format. So this is really what this is, right? And the reason why you do this is, well, that's the kind of how you have to do it. You first put the string, and then you put the arguments that have to be put into the string, and then you put all of that into the format method, which is okay for single lines, but for text blocks it gets weird because then format is at the very beginning, and then you have a bunch of text, and then at the bottom. Anyway, that's weird. So instead, what you can do now is you can say this dot formatted, right? It's super small, nothing big and fancy, but still a nice thing that now formatted is an instance method that behaves exactly like the static method format. Now comes the big part. Let's go to Java 16. Let's go to Java 16. Where's the point? Go. Let's re-import, because Java 16 gives us records, and I'm sure you've heard a lot about them. So I'm not gonna, go through like all these things and go through the entire explanation of records. I just want to give you a short example here. So let's start. I have this repository thing here. This is a repository, and this repository really just wraps a string. Like, it doesn't do much more. And so I need all of this code to have a field and to check something, and then to return the field, and then have equals and hash code and a reasonable two-string implementation. And I don't need any of that to write myself, right? That's something that is just canonical, and that's what I can do here. So I just turn this into a record, which has the form of field as a component now. I'm going to kill the equals and hash code implementation in two-string because the ones that I get from records are fine enough. And then here I have the checks in the constructor, and I can keep them around. I can make them a bit shorter. Like, I don't need to have this here. This is now called a compact constructor. I can just call require non-null. So now I just do the checks here, right? So this constructor here gets, so it's compact constructor. It's a compact canonical constructor. It gets all the components values, and now I can apply some checks. And then at the bottom here, implicitly, it does this identifier, this identifier. And now I could go to all this code base and do that in a bunch of different places. But I want to show you one specific application that I find interesting. And that is something that I do here. Do you see this? Map string. What I need to do here is I get a line, and I need to take the line apart into a key and a value. And so, well, what do I do here? Like, I could write my own class, right? I mean, that would probably be the proper way to do this. I mean, copy some code from off screen. The proper way to do this. I create my own class, which is a front matcher line, has a key and a value, and has the accessors and the constructors and all of that. And then this is what I'm going to return here, right? And that's what I should have done in the first place. But it hurts. Like, it's so it's so much code for just like a little pair, and then you wonder, is that really necessary? I mean, we already have the key, the thing lying around, the map entry, right? It already wanted to do, and so then we have this tension between creating the code that we want to write for readability and not wanting to add all of this boilerplate, which actually reduces readability again. And with records, we don't have that anymore. But I can turn this into a record now, and now this is just a single line. And I didn't implement equals hashcode toString because I was too lazy for that. So if you had a situation where you quickly need a pair or a triple or something like a list plus something else, right? All of the situations where you want to quickly put something together. In the past, you always had to struggle. Do I make this a proper class, or do I have some hacky way of doing it? And now you can always create a new class that has a good name, has exactly the fields you want. It can even have like a constructor to verify a few things if you want to. But if you don't, it's just a single line of code. And it gives you a very short way to create much more expressive code that really shows what it wants to do. Okay, so now I need some advice from the organizers. So we have like 10 more minutes, right? Should we go into questions and answers, or should I show some more code?
I think we could show some more code because I think we will have questions, but we have a time for them, so we can continue.
So until what time? So like 10 more minutes, is that okay?
Yes, I think we have more 10 minutes. Yes, it's okay.
Okay, good. Just wanted to make sure. Okay, so let's go to Java. Wait, just go to 18. I want to go to 17, of course. Okay, so let's keep doing this then. Let's go to Java 17. All right, actually, oh my God, how could I forget that? I forgot something really cool. I forgot type patterns. Oh my God, look. One of the best things, and I skip past it. You see this? Much of this code, by the way, is not code you would actually write that in production. Much of the problems that are solved here, they're already better solutions. It's just really hard to cram like a bunch of these features into a small code base that I can then still explain and go through while still kind of making sense. So what's going on here is I have a class called post. It's actually an interface. And that interface does not have a property or a method that returns a repository. Repository is actually a GitHub repository because there might be a GitHub repository associated with a talk, for example, or with an article. And so what I do here is I need this repository though. So basically I have a post, I need a repository, but there is no repository method on post. So what I do instead is I check, hey, if post is an article, I can cast post to an article and then get the repository. And if it's video, I can do the same with video, and then access, because that video and article, they have these methods. But the other ones, the other post types, they don't. And so what I can do here is now say, like, look, what we do here is a type check, but then we still have to go the extra mile to create implicitly a new variable and cast it. Well, why is that necessary? And it's not necessary anymore. In 16, you can say article here, and then use article down here. And this creates a new variable of that type if post is actually an instance of article. And this is the first pattern that we have in Java. It's a type pattern, but it's part of a bigger picture. It's part of the bigger picture of pattern matching in general. So there are other patterns, and if we get around to them, I can show you one more. There are other patterns that we can apply here, but this is specifically is a type pattern which just checks, is the variable of this correct type? And if it is, I create a new variable with the new name that I give it, and that is already of that type. So that's also something that we did that was added in Java 16. I should say finalized. Many of these things were preview features before, but I'm only going to talk about when they were finalized. We're going to come to preview features later if we have the time. Now let's go to Java 17, and let's do something that might not seem terribly meaningful yet. This post is something that is core to my domain model. And as is often the case when something's that core, you cannot actually have like all the possible implementations, right? You actually know how many implementations you're going to have. This thing that I wrote here that deals with articles, videos, and talks. And it cannot really very well deal with something else. You cannot just throw an additional implementation of a post and expect it to just work, right? There's different places in this code base that assumes that these are the three implementations, just because the domain logic requires that. And so what we can do now in Java 17 is we can say, look, I'm just going to permit these implementations and no other ones. We're going to say it's article, video, and talk. And no other class can then implement this interface. So let's go to, so first of all, I already get compile errors. And the reason for that is that these classes then have to fulfill certain requirements. And I don't want to go into them now because there's a bunch of those. But I'm just going to fulfill them anyway. One way to do that is to make these classes final. So that's what we're going to do here right now. I still have something red here. So what's IntelliJ complaining about here? Oh yeah, right, of course. I forgot sealed, the keyword sealed. Yes, so this is called a sealed type, a sealed interface, or sealed class, which means inheritance is limited to the specific types that I mentioned here. And no other, if I create, like, for example, if I remove talk here and then go to talk, I will get a compile error that it cannot implement post. This is interesting to model a domain and to express to your fellow colleagues as something that where you have a specific consideration about the domain model, specific notion, and you want to limit it to that, but it doesn't have any effect yet. We'll see the effect later if we get to that. And so we don't stand around too long. Let's try to get to that. Let's just skip more of 7. There's more stuff in 17. There's more stuff in 18. There's only preview features in 19. But let's go to the preview features now. So preview features are a little bit more difficult to configure. So I'm not going to go through that now. In the interest of time, I'm going to throw away everything I just did, like just everything. And then I'm going to grab a specific commit. There you go. I'm just going to grab a specific commit, which is enable preview features here. And all the changes that I just did now, the proper versions of those, the ones where I really like set out and did this properly, they are all in here now. So you can see the permits here. This is the good way of applying all of these changes. And I'm going to do that now so that I can show you something in the preview feature. And that would be in the reboot genealogist, for example. So here, for example, I did this type checks, right? I did these individual checks. What I can do now is I can do this. Look, I can say, we're gonna switch over the post. And now in Java, hopefully finalized in 20, but in 19, it's still a preview feature. I can use patterns in switch. So I can say, case, this post is actually an article. Then let's call article.repository. And now I can do the same thing for video. And then we know that there's a third one, which is called a talk. But I'm not gonna give that a variable because I don't need it. Because there is no talks don't have a repository with them. So let's import that class. Okay. And now the cool thing is, the compiler knows that these are all the possible implementations. So this actually compiles. Let's kick this out. If we kick this out, we get a compile error. The compiler says, look, you didn't cover all cases. Let's run the build script. The compiler says, all right, I should probably switch to 19 then, right? If we want to do this. Compile errors take a while sometimes. There we go. The switch expression does not cover all possible input values. We had this problem earlier. Earlier, we added a default branch elsewhere, but we don't need a default branch. We can just say, look, now I covered all cases. How do we know we covered all cases? Because post says so. Post says, I only allow these 3. And that means that once we've covered all 3, the compiler is happy. And that is great, because what that means is if you add an additional implementation of post, every place in your code where you did something like this, where you switched over the type, you will get compile errors everywhere. So you can follow up on them and you can fix them. The visitor pattern achieves something similar, or actually almost the same thing, but much more overhead. So the idea is that you have a hierarchy of types and you have a hierarchy of operations, or rather a set of operations, and all operations should apply to all types. How do you make that work without adding each operation to each type? So far, the visitor pattern is the answer, but this is the better answer. The better answer is to switch over the type, as counterintuitive as it seems at first, and rely on that you know how many types there actually are. And if you add another type, you will get a compile error. So that's really a really big thing. Okay, I think let's quickly go back to the slides and go over a last couple of things. So there's the slides here tell you what we've seen and what we haven't seen, but that's for the talk in full version, which we didn't look at. So let's just skip this. What I want to show you a little bit is Java 17 performance improvements. Look at the left bar, which is JDK 8, and look at the second from the right bar, which is JDK 17. The one on the very right is a much larger heap. Yeah. So anyway, so Java 17 also got faster. You got that additionally.
Hey, Nicolai.
Yes.
Thank you very much for this speech.
Let's say I'm done.
Yes, thank you very much for the speech. It was really great. And even though all these technical issues, we could finish approximately also your speech. So thank you very much. It was really interesting to understand
Yeah.
what's the future of Java and how to prepare to it. So we have questions, but I think we could. I will ask only a few of them because we slightly run out of time. So, can the
Yes.
sealed feature help in the switch case to avoid default statement?
Yes, exactly. That's exactly what it's there for. You want to seal the super type so that you know exactly which subtypes they are, and then you do avoid the default. And that is good because if you add an additional implementation, you will not silently slip into the default branch. Instead, you will get a compile error, and then you can go to the switch statement and figure out, okay, so how does this new type fit in here? What should I do for this new type? That also means that if you want to have that situation, you want to generally avoid the default state. Because of course you can still use default if you want to, but then you will always fall into that branch. If you use a sealed type, you probably want to avoid default and then make sure that whenever you add a new type, you get compilers.
Okay, thank you very much, Nicolai, for your explanation and for your speech.
Yeah, thank you again. Thanks for having me. I want to say sorry once again for the chaos. I wish everybody at the conference. Yeah, and you're doing a great thing here. Thumbs up.
Okay, goodbye, Nicolai.